Hey everyone, today we're looking at the paper Unsupervised Translation of Programming Languages by a bunch of authors from Facebook AI Research. The paper uses sequence-to-sequence models used in neural machine translation in a slightly different way to translate not from natural languages but across programming languages such as from C++ to Python or to Java or vice versa. And they developed some models to do this translation across those three particular languages, and their models are using unsupervised neural machine translation approaches, so they're not relying on parallel training data, but they can learn to translate functions across those languages only using raw code which they get from GitHub projects. So they developed their approach, which is called a transcoder, I believe, and they tested on those languages, and they also composed a new test data set consisting of 852 parallel functions which come with unit tests to check the correctness of the translations, whether the translated functions will actually produce the same outputs as the original functions, which is pretty cool. And it's an interesting approach because existing methods for translating across languages typically rely on rule-based methods. Basically, they take these functions and then they convert them to some sort of an abstract representation, and then they convert from the abstract representation to the target language. This is done by defining a lot of manual rules for conversion, which can be very labor intensive. It can be taking a lot of time, and in general this problem of translating across languages can be very laborious, and automating this can be very useful for extending support to deprecated code bases, migrating them to a newer programming language, for example, or in general saving a lot of manual effort that programmers have to do nowadays. So basically the authors compose a dataset of about 2.8 million GitHub repositories in the three different languages, C++, Java, or Python. And they use the raw code to train kind of three type of models, or train models using three type of objectives, which are all unsupervised. So the authors assume you don't have access to any parallel data, but you just have your raw projects, and then you train these models to do the translation. So in particular, their approach consists of three components. First of all, you have a cross-lingual masked language model for training component, which takes large amounts of pieces of code in one of the languages. Let's say I think this probably is Java, or I don't know, maybe C++. So you take this input code, you're gonna be masking some of the tokens at random. Let's say if or int here, and then you're going to be training a model to predict the masked tokens, similar to something like BERT. So this is done again using just single language, taking a large number of functions and training this model to predict the masked tokens. The second type of objective is a denoising autoencoding objective, which again takes a chunk of code, corrupts it using again randomly, for example, masking function definitions or any type of token here, but then instead of using a cross-lingual masked language model, you are using a whole machine translation model to translate from the noised text to go back to the recovered code, to predict the whole piece of code altogether. And then the third component in this approach is back translation, which is actually training two machine translation models jointly. You have a model, for example, trained to translate from Python to C++, and then you use this output to train another model to go back from C++ to Python. And you keep training those two machine translation models in a loop. You generate some data using the Python to C++ model, and then you go back from C++ to Python, which is your starting point. And you keep doing this over and over again until you kind of end up having pretty decent or decent enough models for both Python to C++ and C++ to Python. And kind of the key with this is that you're going to be relying on having good starting points for these models, such as you could use the models trained on the denoising autoencoding objective as a starting point. So they do a lot of experiments, the authors, for translation across the different languages, all possible pairs. And so they did try also some classical evaluation metrics like BLEU, but their computational accuracy metric is perhaps the most interesting because it directly evaluates the utility of the translated functions. Like, are they able to produce the same outputs as the functions in the original language? And basically they try a number of different variants here in this table, and they compare against some rule-based baselines and different flavors with different beam sizes of the transcoder neural approach. And they find that actually the transcoder is able to consistently outperform the rule-based approaches. In particular, somehow it seems that having a large beam size really leads to some benefits into the transcoder outputs. And also one interesting fact is that they actually leave the comments in these functions during the training intact. I forgot to mention this earlier, but they find that leaving the comments seems to be beneficial because it provides some sort of an anchor point for the translation models, because the comments across the different translation, because across different programming languages will still be roughly similar potentially, which might be helpful to learn better translations. And then they find that translating, for example, from C++ to Java or Java to C++ works pretty well. Actually, they even get up to 92% here for Java to C++. If you look at something like Python to Java, there it's working a little bit worse, because this is a much more difficult task intuitively, because Python, you need to infer the variable types. For example, Python is quite the differences between Python and Java are much larger. Let's put it like that. And there's also some examples in the paper where they show how this works, and also some cool analysis of how this works in the appendix. I would encourage you to check that out on your own. So in overall, this is a very cool application of machine translation, in particular unsupervised machine translation approaches for translation of programming languages. One thing that would have been perhaps interesting to have. In addition, I'm curious, okay, to what extent, obviously this is making a pretty nice improvement over the rules-based approaches. We're getting some improvements in terms of accuracy. So this will lead to some time saving. But I'm curious how far off we are from completely automating this task, and how much of an input of a human do you need still, because obviously you're still going to be getting some mistakes, so you're still going to be you're going to have to check potentially a piece of code as to whether it is valid or not. But with this approach, and also with this metric, or maybe if you have some tests, you can automate quite a large chunk of the manual labor, which is pretty cool. So thanks for watching, and talk to you next time.